Discuss the chemistry of Lassaigne's test. Now, Lassaigne's test is very interesting. It is used for detection of nitrogen, sulfur, halogens or phosphorus within organic compounds. How do we actually perform Lassaigne's test? We take a sample of any given organic compound, we add it in a small tube, and then we add metallic sodium. Metallic sodium, yes, sodium is very reactive. We add them, melt and fuse them together. Molten sodium, because it's very, very reactive, it destroys the given organic compound, takes out all the nitrogen, phosphorus, sulfur, halogens, and forms different compounds. And those different compounds or species can be specifically tested using specific reagents. And this overall process is called Lassaigne's test. Take a look. If you have nitrogen, and organic compounds obviously possess carbon. So carbon, nitrogen and metallic sodium, they all combine and you get the most poisonous and dangerous sodium cyanide. Oh my God. And if you have sulfur, it forms Na2S. If you have halogens, they form NaX. One thing which is not mentioned here is a rare exception, and that is if you have nitrogen and sulfur both, then you don't get either NaCN or Na2S. You get NaSCN. They combine together to give you thiocyanate ion. This is also, if you have only nitrogen, other than, see, organic compound will always have hydrogen and carbon. But if you have only nitrogen, you get sodium cyanide. If you have only sulfur, you get sodium sulfide. If you have both nitrogen and sulfur, then you get sodium thiocyanate. Okay. And how are these species tested? But this is the real fun part. So step 1, organic compound, sodium, heat, fuse, and then extract it with water. Add the thing to a solution of to water, cold water, so that that solution contains either one or more of these species. And now this solution, after filtering, will be tested. How exactly? Let's see. After adding the fused mixture in water and filtering, you have a solution. This solution is divided into 3-4 different parts. In the first part, you add a little tiny bit of ferrous sulfate. Ferrous sulfate, and acidify it also because you have sodium, etc. The solution might be alkaline. So before that, you add some dilute sulfuric acid, make the solution acidic, and along with add ferrous sulfate. You will find, in case cyanide ion is present, cyanide could be dangerous, but adding ferrous locks it up as ferrocyanide ions, FeCN6 4-, and these are non-poisonous. These ferrocyanide ions, they don't have a very significant color, but now just add a drop of ferric ions. First you added ferrous sulfate, now just add a drop of ferric ion. Okay. Otherwise ferrous is already present. Add some quantity of an oxidizing agent like a drop of nitric acid, concentrated nitric acid for example. And even if some ferrous gets oxidized to ferric, you find that this ferric with this ferrocyanide would create a very beautiful dark blue precipitate of Prussian blue. Ferriferrocyanide? Yes, ferriferrocyanide. And this blue precipitate, a dark blue precipitate, the so-called Prussian blue precipitate, confirms the presence of nitrogen in the original organic compound as per Lassaigne's test. Let me move aside, just take a look at the reaction written here. You could note that down. This is Lassaigne's test for you for nitrogen. What about sulfur? Sulfur would be forming sulfide ions. Sulfide ions can be tested with sodium nitroprusside. Sodium nitroprusside, yes, perfectly. And what is sodium nitroprusside? This is nitroprusside ion. It's faint brownish yellowish solution. If you add sulfide to this, suddenly it becomes violet coloration. Even if very small quantity of sulfides are present, still it's a very clear, distinct test. A very distinct violet coloration gives you a confirmation that sulfide is present, which confirms the presence of sulfur in the original organic compound. What about halogens? Halogens they're very easy, they'll form halides like chloride, bromide, iodide. You add silver nitrate, first acidify them and then add silver nitrate. You get either AgCl or AgBr or AgI as precipitates, and then add aqueous ammonia. If AgCl is present, AgCl will dissolve completely in aqueous ammonia, giving you a colorless solution. AgBr dissolves partially with difficulty if you have dilute ammonia especially, and AgI fails to dissolve in dilute ammonia absolutely. But nonetheless, this is again a beautiful confirmation and distinction as well for chloride, bromide as well as iodide. These are Lassaigne tests for nitrogen, sulfur and halides.